Welcome back, guys. We're continuing the second part of the applications to trigonometry lesson. And in this lesson, we're going to have a look at one of the challenging questions where we're dealing with multiple bearings, but also might result in a little bit more of a complicated diagram before we get into solving for any side lengths or angle sizes. Right, so let's jump in and read the question first. So two groups A and B view a rock feature from different positions on the road heading east to west. Right, so the first part of the statement is there's a road that's heading east to west. Group A views the rock at a distance of 235 meters on a bearing of 155 degrees T, while Group B views the rock on a bearing of 162 degrees T at a different point on the road. Alright, so let's start by breaking this down and drawing a diagram for the situation. Right, drawing the diagram is the most important part of solving any application questions in trigonometry. Right, so the first thing I can see from the question is there is a road that heads from east to west. So there's a road that heads from east to west. So let's just draw that road. I'm going to represent that with a straight line. So east to west. So that's the direction from east to west. Right, so we have a road that's heading in that direction. Right, so and there is a rock feature. So group A views the rock at a distance of 235 meters on a bearing of 155 degrees T. So let's just draw a rough diagram what that's going to look like. So 155 degrees T, right? So true bearings, we measure it from the north. So 0, 90, 90 plus 65 degrees. So somewhere in that vicinity. So that's where the rock is. So 65 degrees. I'm going to mark that. So 90 plus 65 gives me 155 degrees T. Right, and that's somewhere where the rock is for Group A. Right, Group B views the rock at a bearing of 162 degrees, right? So Group B is 162 degrees, right? So 162 degrees for Group B, right? So 90 plus 72 degrees, so a little bit more straighter than the previous one. That's the bearing Group B is watching it from, right? And they both the groups are on the same road at different points, right? So and the rock position is exactly the same for both the groups, right? The only thing that changes is where the two groups are placed. So just looking at the diagram here, right? What I can conclude here is Group A is looking at the rock further down the east direction compared to Group B. Right, so it'll make sense when we put the diagram into perspective. So, and what I can also conclude is that rock is on the southern side of the east-west line. So I'm just going to start by putting Group A first. So I'm going to mark my Group A. All right, I'm going to call this Group A, and I'm going to represent that diagram. So I'm going to mark a compass there. That's my north direction. Right, so 155 degrees. True bearing for Group A, so 90 plus 65, so somewhere there, and that's going to be the position of, we're going to call this a position of the rock, so 235 meters. I'm going to mark that as 65 degrees there, right, to represent the 155 degrees true bearing. Now Group B is on a higher bearing, so 162 degrees, right? As we notice in the rough diagram, that line is a little bit more straighter compared to the one for Group A. What that tells me is, that Group B could possibly be somewhere there, right? Because if I want to draw a straighter line, that tells me that the Group B is a little bit more closer to the rock compared to Group A, right? And that's why the line is going to be a little bit more straighter. So 0 degrees, again it's a true bearing of a 162 degrees, so 0, 90, 90 plus 72. Right, so as you can see, the line for Group B is a little bit more straighter compared to the line for Group A, and that's because Group B is at a greater bearing compared to Group A. Right, so I'm going to mark my 72 degrees there. So 90 plus 72 gets me to 162 degrees T. Now obviously, since we're dealing with right angles, right angle triangles in particular, what I'm going to do is I'm going to complete my right angle triangle by just drawing a vertical line from the rock, right? So I've drawn a vertical line from the rock, and that gives me two right angle triangles that I can see, the smaller one with group B and the larger one with group A. So the first part of the question, how far south of the road is the rock feature, right? So in other words, what the question is asking is how far is that distance, right? So we're going to mark that as X for the moment. Now in order to find that distance, the only triangle I can take into account is the one that's with group A. The reason for that is in the triangle with group A, I not only have an angle, but I also have a distance given to us. On the other hand, for the one with group B, the only information that I have is an angle, right? So just with one piece of information, we can't solve for the remaining triangle. So that's why I'm going to take into account the bigger triangle, so the one with group A. So I'm just going to draw a rough diagram for that here. Right, so that's the distance X we've called in the previous diagram. That was 65 degrees and that was 235 meters. Right, marking my sides opposite. Oops, my bad. That's the one opposite of the right angle, so that's going to be my hypotenuse. The side opposite of 65 degrees is my opposite side, and the third side is my adjacent side. Right, so the ratio that we're going to pick here, we need to find the opposite side. We have the hypotenuse, so we're going to pick the sine ratio. So sine theta, so I'm going to write that down. Sine theta equals opposite over hypotenuse. Substituting values, so sine 65 equals X over 235. Right, multiplying both sides by 235 gives us X is equal to 235 times sine 65. So I'm going to put that into my calculator now. So opening up a calculator page, right, we need to make sure that our settings is in degrees. So 235 times sine 65, control enter, gives me in decimals. So the distance for X is 212.98. So X is equal to 212.98. So that's the distance of the rock feature from the road in terms of how far south it is. So the rock feature is 212.98 meters south of the road. So I'm going to go back and represent that in this diagram as well. So X equals 212.98 meters. Alright, let's jump to the second part of the question. Find how far east the rock feature is from group A as well as group B. So with respect to group A, right, my triangle that we did in the previous part of the question is in that format there. So 65 degrees, 235 meters. That's my rock feature. That's where group A is. Right, the question is saying how far east the rock feature. So that's this distance they're talking about. Right, how far east. So that's the east direction. Right, I'm just going to call that Y to start with. Right, label the sides again. Hypotenuse, opposite side, adjacent side. Right, so the two sides we're dealing with is adjacent and hypotenuse, so we can go ahead and use the cosine ratio. So cos theta equals adjacent over hypotenuse. Right, substituting values. Cos 65 equals the adjacent side Y over 235. Right, so if we multiply both sides by 235, right, the 235 goes into itself once, right, leaving us with Y equals 235 times cos 65 degrees. Right, we put that in our calculators. So 235 times cos 65 gives a distance of 99.32 meters. So 99.32 meters. So the distance that point A, or group A, to the rock in terms of the east direction is 99.32 meters east. right? Similarly, the question is asking us to find how far east the rock feature is from group B, right? Let's just go back to this main diagram. So we're basically trying to find out how far east group B is from the rock. So in other words, I'm going to take into account the smaller triangle. Now, in terms of the smaller triangle, the angle is 72 degrees, right? That's where group B is. That's where the rock is. We're trying to find out what that distance is, right? Obviously, we need a side length, and we've already worked out how far south of the road the rock is in part A. So we're going to use that information. That was 212.98 meters, right? So we're going to use that distance along with the 72 degrees to work out how far east of group B the rock is, right? So I'm going to call that distance as Z. Alright, labeling the sides again like we did in the previous two parts. Hypotenuse, 72 degrees is the given angle, so that's going to be my opposite side, and the distance we're trying to find is going to be my adjacent side. So in this question we have the opposite side, we're trying to find the adjacent side, so that's going to help us pick the tan ratio. So tangent ratio is the only one that deals with opposite and adjacent side. So tan theta, so I'm going to write that down, tan theta equals opposite over adjacent, so substituting values, tan 72 equals, the opposite side is 212.98, adjacent side is Z, right? In order to solve for Z, we need to swap the two, right? So Z is going to be equal to 212.98 divided by tan 72 degrees, right? So I'm going to go ahead and put that in my calculator. Right, so 212.98 divided by tan 72 degrees gives me a distance of 69.20. So 69.20 meters, right? That is the distance of group B from the rock in the eastern direction. Right, moving to the last part of the question, right? The question wanting us to find how far is the distance between groups A and B, right? So the distance between group A and group B is basically the difference between how far east the two groups are from the rock, right? Group A is 99.32 meters east of the rock. Or in other words, the rock is 99.32 meters east of group A, and the rock is 69.20 meters east of group B. So the distance between the two groups is simply going to be the difference between these two values, so 99.32 minus 69.20, right? So putting that into my calculator, 99.32 minus 69.20 gives me a distance of 30.12 meters. That's going to be the distance between group A and B. Alright, and that completes this question. Right, as you can see, there are different parts of this question, and that just adds to the complexity of the question. Right, thank you for watching and have a lovely day.